A particle moves with the position function r of t equals t squared negative t and 2. Find the normal component of acceleration. So starting out with the formula, a sub n, which is the normal component of acceleration, that's going to be the length of r prime of t cross r double prime of t all over the length of r prime of t. So in order to use this formula, let's first calculate r prime and r double prime. So r of t is given to us as t squared negative t and 2. Taking the derivative, we have 2t negative 1 and 0. And then the second derivative will just be 2 comma 0 comma 0. Now let's find the length of r prime of t. That's just going to be the square root of quantity 2t squared plus negative 1 squared plus 0 squared, which is the square root of 4t squared plus 1. So what's left is taking the cross product and then the length of that. So r prime of t cross r double prime of t will just be the 3x3 matrix ijk in the first row, and then r prime of t, which is 2t negative 1 and 0, and then r double prime t, which is 2 0 0. Now we want to find the determinant, which we can use some tricks here. Why don't we take advantage of the zeros in the last column? So all you have to do is use these guys and then just start with k. So k is the first row last column. So you have k outside, and then parentheses we have 2t times 0 minus 2 times negative 1. Well, 2t times 0 is just 0, and then minus negative 2, which is positive 2. So that's going to give us 2k. And then with these guys, in the 0 here, that means I and j must be 0. So that's why we have 0, 0 in the I and j component, and then 2 for k. And taking the length of this vector, that's just going to be length 2. So now we just plug in what we have. We said that the denominator, the length of r prime of t, is the square root of 4t squared plus 1. And then the length of r prime of t plus, cross r double prime of t is 2. That gives us 2 over the square root of 4t squared plus 1. And that is our final answer.